Hello again. Now that we've learned a number of different statistical measures, it is important to know which measure is best in different situations. So let's look at the following example, and we should be able to gather some information from that. At Mr. Hightower's company, there are 11 employees, including Mr. Hightower, the president and CEO of the company. The salaries are shown below in the table. So the lowest one is $29,000, and the highest is clearly the $1,250,000. We can see 5 at the top and 5 at the bottom, leaving $42,000 as our Q2 or our median. Of the 5 smallest numbers, we can go right to the middle and see that 33,000 is our Q1 score, and of the 5 highest numbers, 49,000 is in the middle there, so that's our Q3 score. Let's go ahead and try to create a box plot. You'll notice it's going to be a little bit different. We'll put 0 down here as our smallest value, and we'll go up to put a million, not quite at the end, and we'll put 1,250,000 a little bit further along. Put 50,000 somewhere here in the middle between 1 million and 0, and we'll try to break this down a little bit to try to keep an accurate scale. So these are each $100,000 marks, and put 50,000 mark in here. And to help us draw this, let's zoom in a little bit. Alright, so our lowest value is at 29,000. That's kind of about halfway between 0 and 50. And then Q1 at 33, Q2 at 42, Q3 at 49, just shy of 50. So that tiny little thing's our box. There's our line for our lower extreme. But then our upper extreme is way over here. And yes, that is a quite unusual looking box plot. We're going to come back to that in a bit. Let's also go ahead and use the table below to calculate the MAD. So let's copy our data points down, 29,000 twice, 33,000, and 33,000 again, 41,000, 42,000, 45,000, 47,000, 49,000, and 49,000 again, 1,250,000 at the end there. We added those all up and we get 1,647,000. There are 11 numbers, so we divide and we get 149,727. That's to the nearest whole number for our mean. So let's go ahead and copy that down in our mean column. Feel free to go ahead and pause the video if you need to catch up. Okay, now we're going to go ahead and find the deviation. Subtracting is not nearly as bad because we're really just looking at the 10,000s and thousands place. So we get 120,727, and then 120,727 again, 116,727, 116,727 again, 108,727, 107,727, 104,727, 102,727, 100,727, 100,727, and then finally a big negative 1,100,273. To take the absolute values of those numbers, we'll go ahead and fill in this column. Each of our deviations will become positive, which most of them were. The next one, the last one though, will become our big positive change. Okay, so we've summed those all up and we get 2,200,543. There are 11 data points. So the MAD is 200,049 and 36 repeating. So a rather large MAD score. Okay, in part C, let's go ahead and look at the interquartile range. So our Q3 was 49,000 and our Q1 was 33,000. So the difference between them is 16,000. Okay, so if we're going to compare the mean salary of 149,727 to the median salary of 42,000, which is a better representation of the typical employee at Mr. Hightower's company? Here we would say that the median is a better representation of the typical employee because it is closer to more of the data points. The MAD of 200,049, that also suggests that our mean is not a good representation of a typical employee. Big MAD score means not a meaningful mean. So let's look at the IQ, the measures of variability. The MAD score was 200,049 and the IQR was 16,000. Which of these is a better representation of variability? So the IQR is going to be a better representation of variability between most employees because if we think about it, 10 of the 11 employees have relatively close salaries. Only one of them is far away. So this is not an overly variable or spread out set of data. Most of them are fairly close together. So the IQR, which is a much smaller number, is more representative of the variability in the salaries. Okay, let's look at another example. This one's going to be about test scores on Mr. Hiller's recent test. Clearly, some of these students did not study. So there's 14 test scores. We have to go ahead and put them in order here real quickly. 0 is the first one, then 10, then there are 4 80s, 85, and then 4 90s. Then 95 twice, and then finally 100. Okay, so the lowest score, 0, highest score, 100. That's easy. The middle score, since there's 14, is going to be between the 7th and 8th number. So between this 85 and 90 is going to be our Q2. So that's going to be an 87.5 for Q2. Q1 will be this 80 right here, and Q3 will be that 90 right there. Let's go ahead and make a box plot on the line below. So I'm going to go ahead and make our scale from 0 to 100, divide it in half here, and then try to make a nice even scale counting up by tens. So 10, 20, 30, 40, 50, 60, 70, 80, and 90. So our Q0 is at 0, dot there. Our Q1 is at 80, so a line there. Q2 will estimate about 87.5 right there, and then Q3 at 90. And then our Q4 is at 100. We'll form our box here and connect our lines, and a long line going all the way down to our lower extreme. So again, a very unusual looking box plot. Let's go ahead and now calculate the MAD using this organizer here. I'm going to put the points in order. It'll make our calculations in the next step a little bit easier. So 4 80s, an 85, 4 90s, 2 95s, and then 100. I'm going to scratch out this last line just so I'm not confused by it. There's no number there. The sum of these is 1,065, and there are 14 points. So you divide by 14, and we get 76.07. For our MAD calculations, we're just going to put 76. That'll make our MAD calculations a little bit easier, our deviation calculations a little easier. So filling in 76 for the rest of this column. Okay, finding the deviation, 76 minus 0 is 76. 76 minus 10 is 66. And then we'll get a bunch of negatives. So negative 4 happens 4 times here, and then negative 9. And then negative 14 happens 4 times here, negative 19 twice, and then negative 24. Go ahead and take the absolute value of those in the last column here real quickly. Okay, so we sum all those absolute deviations. We get 285 divided by our 14 data points gives us a MAD of 20.36. Okay, so ignore the typo there. It does need to say test scores on Mr. Hiller's test, so I've already changed that. Please do that on yours. We want to find the IQR for these test scores. So that's going to be 90, our Q3 score, minus Q1, which is 80, to give us an IQR of 10. Okay, now if we compare the mean score of 76 to the median score of 87.5, which is a better representation of the typical score on Mr. Hiller's test, well, the median here is a better representation of the typical score. Why? Because it is closer to more of the data points. If we think about our test scores, most of them were between 80 and 100. Good test score, so 87.5 is much more representative. The MAD of 20.36 also suggests that the mean is not a good representation of the typical score. Remember, high MADs, bad means. Okay, if we compare the MAD score of 20.36 to the IQR of 10, which of these is a better representation of variability? The IQR, again, is a better representation of the variability between most test scores. We can say this because 12 of the 14 students had relatively close scores. There was not a great deal of variability. They weren't varying by 20 in each direction from the mean or anything like that. There was a total variability of 20, so relatively close data scores. So a smaller IQR, smaller variability is what we're looking for. Now if we look at the box plot here, we notice this was weird. There's a very low value here, and the other box plot, there was a very high value here. Both of those were really messing up our data. So we want to know what is the best statistical measure. So when we have skewed data, the best measure of center is going to be our median, because that does not get affected by those scores that are far away. If it's symmetrical, the mean is a great measure. It's going to take into account some of the points on the ends, but it's going to balance them out well. Now for variability, because median kind of is connected with our box plot, as is IQR, IQR is going to be our better measure of variability. And for symmetrical, the MAD. The MAD is bad with skewed data because just like it's based off of the mean, so when the mean's bad, so will the MAD be also a bad measure. Now, what is the best graphical representation? If there's only a few points, a line plot's great. If you have lots of points, you don't want to make a line plot. A histogram or a box plot will work out better. If you're looking for the median, definitely a box plot. It's graphed right there on the box plot. Now, it is possible to do it with the line plot, but you're still just kind of going through all the numbers, finding the middle number. If you're looking for the mean, you need the line plot. Neither the histogram or the box plot can reveal that information. For shape, though, any of these three measures will work for us. So we can see even in this box plot here, there's a long tail to the left. That's saying this is skewed left. So any of those measures can help us find our shape.